Hi, this is Rob Dietrich, and I'd like to show you how you can make your Breakout, your Pong that's turned into Breakout, into something that's maybe a little bit more exciting to look at, a little bit juicier, let's say. So we're going to refine this a bit. So one of the first things I might want to refine here, though, and this is less about the juice and more about presentation, but it's my life display here. It's kind of in the way at the top of the screen, so I don't want to keep that around. So really what I want to do is I want to have, instead of just one text area that I'm manipulating right in the center there, I want to maybe have two text areas, one for the score, one for the lives. And I'll put one in one corner, one in the other. So I'm going to need a couple displays for that, a couple texts to modify. So I'm going to start with the score display here. I'm going to duplicate that. And I'm going to make one of them the lives display. And I'll go ahead, put in some original sort of dummy text here, lives X for this one, and then I'll do the same thing for the other one. I'll say score is X. And now I can start positioning them. I'll say take the score display, and I'll use this guy to move it over into the corner, Shift Alt, so I can set both position and its pivot. And then maybe I want to go ahead and just move it in a little bit. Not a lot of it. Yeah, that's alright. Yeah, shift it down some. Negative 20. Alright, that's alright. 80. I like that better. Okay. And I'll do the same thing, but in the other corner here. Shift Alt. Boop. And let's see. Negative 80. Yeah. And what was the other one? Negative 20, something like that. Okay. So I'm going to split these out into the sides here. Now, you'll remember that in my game manager, I was setting the score into the score display, but I'm going to need to have an extra area for it, an extra parameter here for that, for our lives display. So I'm going to say, okay, there's score text for one, lives text in the other, and where I'm doing that update, I'm going to go ahead and modify that. So let's see, this score text is only going to care about the scores. It's going to be score plus the score, life text, lives text, yep, dot text equals lives, then plus player lives. So I'm going to go ahead and set those there. And now in my game manager script, it should compile, and I'll get the extra parameter here. I'm going to go ahead, drag lives display in there. So having done that, yeah, there we go. Oops. Let's make sure that's working. Okay, yeah. Drag that around, get a score, get our lives. That seems to be behaving. And I died. And while I'm at it, just because it's bugging me, I'm pretty sure I have a font around here. Yeah, I don't want these to be Arial. That looks terrible. It looks better. Come on, score display. Work with me and stop being Arial. Okay, I appreciate that. Well, it looks better. It looks a little bit more intentional. Okay, so we've got our scores looking better, but let's make some things more exciting. So what if when the ball hits stuff, we'll make a nice effect show up. We'll make a nice sort of explosion burst. What if we start using some particles? So particle systems are a good classic way to add some extra visual pizzazz. And they can be a lot of fun, and you can waste a lot of time working on them because there's a lot of configuration you can do. But I'm going to show you some of the basics. A basic effect you can use here. So I'm going to go ahead into my hierarchy. I'm going to create a particle system. When I do that, I'll have a particle system right here. And I'm going to, just for now, turn off looping on that because it's going to put a lot of weight on the capture here. So when you have a particle system, you have a lot of information that will show up in the inspector over here. And it's all sorts of settings. You've got lots of settings, and there's all these areas with even more settings, some of which are enabled or disabled by default. And there you can go a long way playing with this. There is also this other area editor you can use for sort of simulating and testing things. It's all right. I'm kind of a fan of just doing things directly in the inspector, but that's just me. But I'm going to sort of tweak around what we have. So I'm going to go ahead and use looping so it'll automatically play my effect for me. So you see it's these particles flying up into the air. And that's cute, but it's not what I'm looking for. So one of the first things I'm going to want to do here is I'm going to actually lower the duration of this. It's got to be something quick. So I'm just going to go ahead and set it to 1. And one thing that matters here is this lifetime. Start lifetime, the initial lifetime, or the lifetime setting at the start of the particle system. And that's 5. And what that is that is 5 seconds of life. Every particle here lives for 5 seconds. Well, that's too long. I'm going to let them live for 1. And you'll notice they kind of stop off quicker than they did before. Oh, and also with the shorter duration, it also stopped off quicker. So we've got that there. And while I'm at it, I'm going to add a little extra bit here, over here at color over lifetime. And this will change the color of my particles over their lifetime. So if I open that up, I'll get the gradient editor. And this is just a gradient from white to white, which is no change. But I can start changing it, so maybe the other end of the gradient, I'll just go ahead and make that black so it's easy to see. And if I kind of loop our particles a bit so we can see them. There we go. How you doing? We get that showing up. So they're turning black there. And I'll go ahead and do that one better where I'm going to play with the alpha up here. I'm going to turn that all the way down. So in doing that, maybe it will be easier if I use the editor here. Okay, so if I do that, you'll notice our particle sort of popped there and simulate again. You'll notice our particle kind of pops and does that nice little thing. There we go. Stop and then simulate. Boop. And it pops up there. Cool. So our particles will sort of fade out, but that's not quite the, let's say, the shape that we're looking for. So the shape that we want for our particles is probably not what we've currently got. Where right now we're shooting them up in a cone, which is actually a 3D shape. Our particles are actually technically in 3D here. Oh, and they're actually off-centered, so I should go ahead and kind of fix that here. Centered on the screen. It's actually a 3D shape. We just happen to be looking at 2D, but it looks fine. But we don't want it to be over here in a cone. Let's do it in a sphere, so we have something nice and round. And I'll get shape for it. But let's also work with our emission rate. Now right now we have this rate of 10 particles per second. And that's a continuous rate of emission over the lifetime of this particle effect. But that's not quite what we're looking for. I don't want to show it continuously. Instead, I want to do a burst. And that's the option we have here. We have a list of bursts. So you can add a burst here. And what that does is that creates this starburst of particles. And I can control how many particles come from that. And I can even add multiple bursts and kind of offset them by time. So I could use this to kind of do a 1-2 kind of effect. Now I don't need that for my purposes here, but it's nice to know that's there. You could do something with that. Ba ba ba. Something cute like that. So I'm just going to do one little sort of starburst effect. And okay, that's getting there. We can start working with that. But I don't want to use this kind of... oh, actually one more thing I do want to change in there. Is I want to look at this shape. It's a sphere with a radius of 1. Let's go ahead and reduce that a bit. Tighten in this emission here. And also while we're at it, let's tweak the scale so it's a little bit more circumspect. 0.5, 0.5, 0.5. All right, that's better. So we've got this effect popping out here, but I don't want to use this white fuzz for my texture. I want to use something else. And the way you change that is by going into the renderer. And this rendering is based on a 3D paradigm of how you do rendering. So that's kind of affects what some of the text is all about here. So in order to change the texture that I'm showing, change the sprite that I'm showing, I'm going to need to create a new material for it, a sort of a 3D rendering material. And I'm going to create that here. And let's just call this something like the ball impact material. So we've got the ball impact material. Now when you create a material, this is a series of basically rendering settings that you apply to something. You know, it's what textures you want to draw where, what the lighting settings are like, how metallic or smooth is something. And this is affected by what shader you're using. So you hear about pixel shaders. This is where it comes in. And I'm going to pick from some of our standard available assets, and among them we have the particles setting, and among them we have all these sort of different blends for particles. And blends are just like the blends you would encounter in an image editor's layer settings. So you have layers that can be blended into each other. You can multiply colors together, multiply something by gray, and it darkens the color, for example. And what we're going to use here is we're going to use additive. So what additive does is that when images overlap each other, they add color to the layer that's below them. And the more they overlap, well, the closer to white they become, because they get closer and closer to 1. And it creates a sort of a light effect there. So I'm going to use that additive material. It's a fairly simple texture. The big thing that we really want here is this, the actual texture in there. And we're going to take, let's just say our ball sprite. We're going to drop that in there. And once we have that, we can go back to our particle system, go to its renderer, and say, hey, your new material is going to be ball impact. If we do that, we have that nice flash of little spheres happening from the impact. Hey, that's kind of nice, and I might want to go ahead and turn that down a little bit. There we go. It's a nice poof, poof, poof. Now I want to increase their start speed. Let them go a little bit faster. See how that looks. Eh, don't like it that much. We'll go back to here. So you should be careful when you're using particles because it's very easy to just tweak them forever. But right now we're going to say, you know what, we are satisfied with this particle for now. Let's go ahead and change its name. You can do that here or here. Let's call this the ball impact effect. We do not want it to be looping. And now that we've got this ball impact effect that we're okay with, that we're satisfied with, we're going to drop that into our prefabs. And we don't need to keep it in our level. So what are we going to do with this? Well, I'm going to go over to our ball script. Oops, that is over here. And I'm going to modify our script and say, okay, whenever the ball hits something, I want to create a particle, that particle effect. So first of all, I'm going to need a function to call that is called whenever the ball hits something. I can use one of these collision functions, like from the paddle script. I'm going to drop one into my ball script on collision exit 2D, except in this time, instead of on collision exit, I'll go ahead and try on collision enter 2D. And what am I going to do here? Why, I am going to spawn or instantiate a game object. And that game object is going to happen to be my ball impact effect. So here's the variable that's going to contain it. And I can set this to anything really that I want to have around. But I'm going to set it to be my ball impact effect. And let's see, I should have saved. All right, is that public? No, it's not public. So I'm going to make that public so I can access it. Boop. And we'll get that showing up there. All right, ball impact effect. And where is our ball impact effect? Right there. So I'm going to drag that in there. Now with my ball impact effect put together, I'm going to say whenever I'm running into something, I'm going to instantiate ball impact effect. I'm so going to clone it, make a copy of it. This will give me a game object, which is the actual effect I've created. And I'm going to take this effect, and I'm going to set its position equal to my ball's position. So it spawns at the place where the ball is at the time of collision. So if we start with that, let's see what happens. Ball drops. Boom. Nice shiny effect. Boom. Whoa. Boom, 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 boom. Hey, that's fancier. Now, you might want to rewind the video a bit at some point here and just sort of check this out. But while we were playing, you'll notice that these little things started showing up. These little things started showing up in the scene view. I'll actually go ahead and run that again here. So you notice what's happening here is, I'm creating particle effects whenever I'm running into things, but I'm actually just creating new ones every time. I'm cloning new ones, and they're not going away. This can be a mess. If you keep doing that, you'll eventually just fill up your hierarchy with stuff, and your game will get slower and slower as it goes along. But really, this particle effect, this effect that we're making, it ends pretty quickly. So we just need to make sure the game object also goes away. So we're going to make a very common but useful script here, and we're going to call it destroy self. And this destroy self script is going to be on the impact effect. So I'm going to go here, add destroy self. And what destroy self is going to do, we'll load that up, reload solution. Yes, that's fine. Boop. Control Shift F, save everything. It's going to do just one very simple thing. It's only going to do something right at start, and it's going to say destroy game object. It's going to destroy the game object that has the script. And I'm going to use the second version of the destroy function, which actually lets me specify the amount of time before destruction. So I can say, okay, destroy me in 2 seconds. It's a very useful function here. So now that I'm set to be destroyed in a couple seconds, now when I drop the ball in and let it do its effecty goodness, it'll make the effects, but the particle game objects actually disappear over time. They go away. So that'll help my game stay a bit cleaner as I work on it. Good stuff. So now we have fancy particle effects happening, but let's see what else we can do to fancy up the game a bit. Now, one thing you might try is, let's say when we hit these bricks, we want them to kind of pulse a little bit. We'll change their scale. And I'm going to show a little trick that was in that juicing video that I showed you before. And this is a little equation that I end up using quite a bit because it is just that useful. And this is sort of what I think of as kind of the poor man or the lazy man's easing equation. And what it is going to be this. So I'm going to set up a bit of logic inside of the bricks update. I'm going to do it inside of the fixed update. And I'm going to set a little logic here where I'm going to take the scale of my brick. And I'm going to set it up so the brick always wants to go to a scale of 1. So whenever its scale is bigger or smaller than 1, it's going to move closer to 1. That is, it's going to try to return to the sort of this neutral scale. It's going to have this sort of this springy effect to it. So I'm going to write a little logic to do that, and I'll call it something like, let's just say we're going to have the float. We're going to get the current scale, and scale has 3 components, but I'm just going to go ahead, let's grab the local scale. I'm just going to use the X as a proxy for all my scaling parameters. I'm going to scale uniformly. And I'm going to say, all right, the current scale is going to be equal to itself plus 1 minus current scale times time.delta time. So what's this about? Well, I'm taking the current scale and then I'm taking itself and adding something to it. So this whole sort of like current scale equals current scale plus, we can just do that in shorthand and just say plus equals something. So we can say current scale plus equals this. Now what is this? So this 1 right here, this is my target value. I want my ball script to be a size of 1. But what I'm doing here, instead of setting it directly to 1, which happens instantly, I'm calculating out how far I am from it. So if I'm, say, scaled at 0.5 and my target is 1, that means that this is going to be a 0.5. That's the difference between my current scale and my target scale. And what I can do here is I'm going to multiply this by some number. In this case, I'm going to multiply it by the amount of time that's passed since the last frame, which is going to be a pretty small number. And I say, instead of going all the way to my size here, I'm just going to take the difference between my current size and my target size, and I'm just going to move some portion of that for this frame, one tiny sliver of that for this frame. So what else can I do with this? Well, now what I can do is that when, oh yeah, well, first of all, I'm going to calculate this new scale, and then I'm going to set my scale based on that. So that's a vector 3. I'm just going to toss this current scale guy into all of the parameters of vector 3. There we go. So I'm going to set my scale to that. So now what I can do is, let's say when I get hit, when this brick gets hit, I'm going to take its scale, and instead of setting it to something like this, I'm going to use a new variable here, hit time scale, and we'll set it to like 1.25. So the block is actually going to get bigger. Do I want to do it? Let's see what happens if it, let's see how it looks if I make it smaller. I'm going to make it smaller for a bit. I'm going to make the box contract when we hit it. So it's going to change the scale. So now when the scale is less than 0, now the scale is less than 1, it's not at 1, not at a neutral scale. This logic is going to make it move towards 1 gradually. Not just gradually, but as it gets closer, it's going to slow down a bit, which creates a much more of a physical sensation than just like a linear, thoughtless interpolation. And let's take a look at how this looks. It may be kind of hard to see on the size of the screen. Maybe I can make that bigger if the capture is cooperative. Boop. Okay, you can see we actually are sort of squeezing these guys down a bit, and then they slowly pop up to their original size. So that's pretty neat. Now we just want, but it'd be nice to have them sort of pop up back a lot faster. So I'm going to look at this time. I'm moving times time.delta, but let's just say I want to move times time.delta times 10. So not just the number of seconds passed between the frame, but that times 10. So I would have returned to my original size 10 times over in the time of 1 second. So that'll speed this up a lot more, and probably make it a lot poppier. So let's see if I can get some more space for my game preview. Let's twist that up a bit. Oh yeah, so we can see that better. I'll jump in. Boop, get up there. Okay, there we go. So you see now these balls have this, the bricks have a much more springy effect to them as we hit them. Boink, 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 boink. Bloop, bloop, bloop. Boop. Woo, bonk. So instantly we're getting a lot more feedback in our game, and that feels pretty neat. That makes it feel better. Or at least I think that makes it feel better. So, one more trick that, well, a couple more tricks, but one more trick that'll really help dance things up, liven things up for you here is, how about a bit of camera shake? A good classic. So what is camera shake? Camera shake is actually pretty simple. Camera shake is just taking the camera and moving around randomly. So we just need to do what I just did in the editor, just using some code. So I'm going to write some code for that. Let's say we make a script called camera shake. The camera shake script. And I'm going to add that to my main camera. Camera shake. And what I'm going to do with camera shake is I'm going to, first of all, I'm going to give it a big public function called shake camera. And we're going to shake the camera for a certain number of seconds. So shaky. shake seconds. And I'm going to have that be a parameter that I'm setting when I call this function. So I'm going to have a variable to hold that, float current shake seconds. And I'll take whatever value I'm setting in there, shake seconds. And now inside of the update for this, I'm going to say, all right, if the current shake seconds is greater than 0, I'm going to shake stuff. Otherwise, else, I'm going to return to neutral or return to normal. Among that, I want shake seconds to be 0. And while shake seconds is greater than 0, I'm going to reduce it by time.delta. Time.delta time, the number of seconds that passed since the last frame. So this will make current shake seconds count down. So how am I going to actually change where the camera is located? Well, the way I do that is by using a random number. I'm going to take a random number every frame that we are shaking. That could be neat. So I'm going to say, use a little utility here called random. Oops, and I'm not getting my autocomplete, so it should be, I guess, oh, what was the name of that? Oh, I've lost my autocomplete. I'm going to try to see if I relaunch Visual Studio if I'll get my autocomplete, because that'll make this a lot easier to write. Visual Studio 2017. Hello, welcome back. You feeling better, Visual Studio? Can I get random now? Yeah, random dot, what was it? Inside unit circle. So this is going to give me a vector 2 that is inside a unit circle, a random value that is inside a circle. So I'm going to take this inside unit circle value, and that's going to be my vector. Let's just call this the shake amount. And I might want to tune that. This is a good candidate for a tuning variable. I'm going to reduce it a bit to make it not as big. Well, 0.6. And this is a vector 2. And I'm going to apply that to my camera's local position. I'm going to say, okay, now the camera's local position is a vector 3. But I'm just using a vector 2. Why is that important? Well, the camera technically has a z-value. Not just technically has a z-value, it has a z-value. And if I change the z-value too aggressively, I'll actually end up zooming straight into the screen and possibly go past it. So that'll cause my screen to effectively, all my game objects to effectively disappear when the camera temporarily moves past them. I don't want that. I don't want to blink away when I shake. Just going to shake on the X and Y. So I'm only going to change the X and the Y values. And I'm going to stay with my original local position. So I'm going to want to actually keep track of that. So let's go ahead to the top here and say vector 3 starting position. I'm going to set that here, starting position. Whoops. Starting position equals transform.local. I'm going to use the starting positions z, but I'm also going to take advantage of this so I can use it once I return to normal, and I'm going to set my starting position, set my current position back to my starting position. So that way I can make sure that the camera once it's done shaking, it can get back to a normal setup. So this logic should allow me to shake the camera around. Now I just need to actually shake it. So when do I want to shake it? Well, maybe when I lose a life or something. Who knows when I do that? Why, the game manager knows. So I'm going to add a public parameter here to the game manager called camera shake. We'll call that camera shake. And it's a public parameter here. It's a public method, public variable that's part of game manager. And I've got here camera shake. I'm going to give it my camera, which has the camera shake on it. Boop. That'll connect that. And now, at my choice timing, let's see, when I have ball death, I'm going to take camera and say, hey, camera, shake. Shake for a bit. Just shake a little. All right, we're going to shake camera a bit when we break. And how about when we game over, when we finally bite it? Oh, wait, that's not where I do that. That's up here. When I finally bite it, I'm going to shake a lot more. Boom. Big shake. All right, so now when I do that, I'll go through. Ooh, shake. Oh. Oh, okay. So I tried to shake big at the end there. That would have looked cool, but I moved too quickly. I immediately hit the game over part and then go into load scene. So one last thing that we're going to want to do here. So I want to, since I'm bothering to do this, I want to see all that nice shaky stuff. But I'm loading scene too quickly. So I want to delay this. But I don't want to do too much more. It would be kind of a waste to sort of, I don't want to use too much code to do it. But luckily there is a quick way to do this, and you don't want to overuse this because it's a little slow and it's a little garbagey. It creates a lot of sort of memory cruft if used really aggressively. If you use a lot, hundreds of times, thousands of times a frame or something like that, it can cause big problems. But used sparingly, it's a really useful technique. And that is a little function here called invoke. An invoke allows you to run some function. Like let's say we had a function called game over, which we do, but we're going to have to change a few things. So we call a function called game over, and we can decide when we run it. Like let's say we run it in 2 seconds. So when our lives equals 0, we're going to say we are going to call game over, and we're going to do it 2 seconds from now. And what happens when we game over? Well, that's when we're going to load the menu scene. So I'm going to take this code, and I'm going to repurpose this old game over that we had here. I'm not going to play sound. I'm just going to use it to move us to the next place. So now we'll say game over. We're going to go try to run this game over function. It needs to match it here, so I don't want that parameter. So we're just going to invoke game over. It'll be run 2 seconds from the moment our lives went to 0, and that's what's going to make us go to another scene. So I do that. And I drop the ball, and boom, boom, boom. Oh, shake, 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 shake. And then we go to the next scene. Now, we got lucky there, because you notice the ball was falling again, and it might have dropped and scored another ball death. Now, this only happens when we turn to 0, but if we happen to have our logic be less than 0 and the ball actually hit here, there's a chance we would have done a second invoke here. Well, it probably wouldn't have loaded because this got in there first, but it gets a little bit messy, and it's not very elegant to see the ball falling again after we gamed it over. So let's take this chance to actually go ahead and destroy that game ball object. We're going to destroy that game ball so it goes away. That'll stop the game from feeling very much playable anymore. So now when we fall, boom, 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 boom. There we go. That's feeling pretty good. Now, remember this invoke game over, because this might also be useful when you actually go to the next scene. So when you win, you might want to take advantage of this same sort of ability. So instead of trying to load scene immediately, you might make another function that's like go to next scene, and you'll invoke it, give yourself a little time, but maybe that's a great time to go in and make other effects, like have lots of bursts show up everywhere, some nice fireworks to celebrate the player. You know, we are embarrassing the player a bit by saying, oh, you failed so much, we're going to shake the camera at you a whole lot. Be nice and maybe do something celebratory for the player if they manage to win here. And now, just on a lark, what if we shake the camera every time we hit a block. Just a little bit, but it might be kind of neat. It'll be overkill, but it might look kind of fun. I just want to take a look. So let's see. Whoa. Let's get up there. Hit the blocks. Ooh, 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 ooh. That's juicier. Get over there. Hit that. Oh, yeah. Boom, 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 boom. Nice. All right. I hope this video proves useful to you. And I will see you again in class.